Asteroids are rocky remnants from the early solar system, often referred to as the building blocks of planets. They offer a glimpse into a time when planets were forming, providing invaluable information about the processes that shaped our solar system. These celestial bodies hold clues to the conditions and events that shaped our cosmic neighborhood, acting as time capsules that preserve the past. By studying asteroids, we can piece together the history of our solar system. Asteroids vary in size, composition, and location. Some are small like pebbles, barely noticeable in the vast expanse of space. Others are hundreds of miles in diameter, massive enough to be considered minor planets. They are primarily found in the asteroid belt, a region between Mars and Jupiter, where countless asteroids orbit the Sun. This region is thought to be where a planet might have formed if not for Jupiter's gravitational influence, which prevented the material from coalescing. Asteroids are like time capsules, preserving materials from the early solar system. They preserve materials from the early solar system, including metals, rocks, and even water ice. These materials include metals, rocks, and even water ice, offering a treasure trove of information. By analyzing the composition of asteroids, scientists can learn about the building blocks of planets and the conditions under which they formed, shedding light on the origins of our solar system. The study of asteroids is crucial to understanding our own planet's history, including the impacts that have shaped Earth's surface. It also helps us comprehend the potential threats and opportunities that these celestial wanderers present, from possible collisions to mining prospects. The formation of planets is a captivating tale of cosmic choreography. It all began with a cloud of gas and dust. Gravity acted as the conductor, pulling particles together. These particles collided and stuck to each other. Over millions of years, these collisions created larger and larger bodies called planetesimals. Planetesimals continued to attract more material, growing in size and mass. The largest of these planetesimals eventually became planets. In the outer solar system, where it was colder, planetesimals accreted icy material in addition to rock. This is why the outer planets are gas giants. They are primarily composed of hydrogen, helium, and ices. The process of planet formation was not without its casualties. Countless planetesimals were destroyed in collisions. The remnants of these collisions are what we now observe as asteroids. Between the orbits of Mars and Jupiter lies a vast region populated by millions of asteroids. This is the asteroid belt, a cosmic junkyard of sorts containing remnants from the early solar system. The asteroid belt is a fascinating region that tells a story of planetary formation that was interrupted. Jupiter's immense gravity played a significant role in shaping the asteroid belt. It prevented the formation of a planet in that region. Instead, Jupiter's gravity stirred up the material, causing high-velocity collisions that shattered planetesimals into smaller asteroids. While the asteroid belt is often depicted as a crowded and chaotic environment, it is actually mostly empty space. Asteroids are spread out over a vast distance. The distances between them are enormous. The asteroid belt is a treasure trove of resources. Asteroids contain valuable minerals, including metals, water ice, and platinum group metals. These resources have the potential to revolutionize industries on Earth and support future space exploration. Vesta is one of the largest asteroids in the asteroid belt. It is a fascinating object that offers a glimpse into the early solar system. NASA's Dawn spacecraft visited Vesta from 2011 to 2012, providing invaluable data and images. Vesta is unique because it is a differentiated body. This means that it has a distinct internal structure. It has a metallic core, a rocky mantle, and a crust. This differentiation suggests that Vesta was once volcanically active. The surface of Vesta is heavily cratered, bearing witness to billions of years of impact. These impacts have exposed layers of Vesta's interior, allowing scientists to study its composition and history. Section 5, Ceres, an icy world with secrets to tell. Ceres is the largest object in the asteroid belt and is classified as a dwarf planet. It orbits the Sun between Mars and Jupiter, making it a fascinating subject of study for astronomers and scientists alike. It is a unique world with a composition that sets it apart from its rocky neighbors. Unlike other asteroids, Ceres has a mixture of water ice and rock, giving it a distinct appearance and structure. Ceres is thought to be composed of a significant amount of water ice, perhaps even a subsurface ocean. This icy composition hints at the possibility of past or present geological activity. The Dawn spacecraft, after its exploration of Vesta, journeyed to Ceres, arriving in 2015. This mission provided unprecedented insights into the dwarf planet's surface and composition. Dawn's observations revealed a world with a surprisingly diverse surface, featuring craters, mountains, and bright spots that puzzled scientists. These features suggest a complex history of impossibly internal processes. These bright spots are now thought to be deposits of salts left behind after the sublimation of water ice. The presence of these salts indicates that Ceres has undergone significant changes over time. This suggests that Ceres may have been geologically active in the past, possibly with cryovolcanoes erupting icy material instead of molten. Such activity would have shaped its surface in unique ways. Ceres' potential for harboring water ice makes it a compelling target for future exploration. Scientists are eager to learn more about its potential to support life or provide resources for human missions. It could hold clues to the origins of water in our solar system, including the water that makes life possible on Earth. Understanding Ceres better could unlock secrets about the early solar system and the distribution of water. Section 6. The Late Heavy Bombardment, a cosmic cataclysm. The early solar system was a chaotic place, filled with swirling clouds of gas and dust and countless rocky bodies. Leftover planetesimals and asteroids bombarded the inner planets and moons, leaving their mark on their surfaces with countless craters. This period of intense bombardment, known as the Late Heavy Bombardment, occurred roughly 4.1 to 3.8 billion years ago, reshaping the surfaces of many celestial bodies. Evidence for the late heavy bombardment can be seen in the heavily cratered surfaces of the Moon, Mercury and Mars, which bear the scars of this ancient cosmic event. Earth would have also experienced this bombardment, but geological processes such as erosion and plate tectonics have erased most of the evidence, making it harder to trace. The late heavy bombardment is thought to have been triggered by gravitational interactions between the giant planets, particularly Jupiter and Saturn, whose immense gravity influenced the orbits of smaller bodies. These interactions caused shifts in the orbits of asteroids and comets, flinging some of them inward towards the inner solar system where they collided with the inner planets. While the late heavy bombardment was a destructive period, it may have also played a crucial role in delivering water and organic molecules to Earth, potentially contributing to the origin of life as we know it. Section 7. Cosmic Threats and Planetary Defense Guardians of our Pale Blue Dot. As remnants from the early solar system, asteroids pose a potential threat to Earth. While large impacts are rare, they can have catastrophic consequences, as evidenced by the Chicxulub impact that wiped out the dinosaurs. Scientists and engineers around the world are actively working on planetary defense strategies to protect Earth from asteroid impact. This includes early detection systems to identify potentially hazardous asteroids and deflection techniques to alter their trajectories. Telescopes constantly scan the skies, searching for near-Earth asteroids. Once identified, their orbits are carefully tracked and analyzed to assess the risk of impact. If an asteroid is deemed a threat, various deflection methods are being developed. These methods include kinetic impactors, gravity tractors, and even nuclear options as a last resort. The goal is to nudge the asteroid slightly off course, enough to avoid a collision with Earth. Section 8. Asteroid mining, a new frontier for resources. Asteroids are not only potential threats, but also potential sources of invaluable resources. They contain abundant minerals and metals, including platinum group metals, which are rare on Earth. Asteroid mining has the potential to revolutionize industries and support future space exploration. Water ice is another valuable resource found on some asteroids. It can be used for life support in space, as well as broken down into hydrogen and oxygen for rocket propellant. This could make space travel more sustainable and cost-effective. Several companies and space agencies are developing technologies for asteroid mining. These technologies include robotic spacecraft, mining equipment, and processing facilities to extract and utilize resources in space. Asteroid mining is still in its early stages, but it holds immense potential for the future. It could provide a sustainable source of resources for Earth and enable us to expand our presence beyond our home planet. Section 9. Conclusion: the enduring fascination with asteroids. From their ancient origins to their potential to both threaten and benefit humanity, asteroids continue to fascinate scientists and the public alike. These cosmic time capsules offer a glimpse into the early solar system and hold clues to the processes that shaped our cosmic neighborhood. As we continue to explore and learn more about asteroids, we gain a deeper understanding of our place in the universe. The study of asteroids is not just about rocks in space. It is about unraveling the history of our solar system, protecting our planet from cosmic threats, and unlocking the potential of space resources for the benefit of humanity.